Hello and welcome back to another video about Algebra 2, and today we will be covering section 1.5 on scatter plots, correlations, and least square lines. So you guys will learn how to graph a scatter plot and how to identify correlations by using the scatter plots and how the graph looks like, and also learn about least square lines and how to find them. So let's get started. So first we have this table right here with the title as Chickenpox in the United States, year and reported cases in the thousands. So the year, as we can see here, is 1989. And reported cases 185.4, and then year 1990, 173.1, 1991, 147.1, 1992, 158.4, 1993, 134.7, 1994, 151.2. So first, what we're going to do with this is we're going to try creating a scatter plot. So what is a scatter plot? So basically, a scatter plot is just all of these points graphed. And because it's very hard to do like large numbers on a scatter plot, for a scatter plot, or just graphing in general, pretty much, because the numbers get very big, and to do that on decimals I have to like zoom all the way out, which is little hard. We're going to make the year as years after 1988, so it would make 1989, for example, 1. So if we do that, the points would be 1,185.4, 1,185.4, 2,173.1, 173.1. So yeah, we can find this if we zoom about here, yes. And then 3,147.1, 4,158.4, 5,134.7, 6,134.7, 6,151.2, 6,151.2. There. So now we have all our points here. And as we can see, the graph looks like this as it's sloping down. So basically what we can do with this is make an inference. So basically, what do I mean by that? So inference. We're going to make an inference about this. And to make an inference, we need to look at these three right here. So a positive correlation with scatter plots would look like this. It slopes upwards. So in a normal linear graph, it would have a positive slope. Negative correlation is just exactly the opposite, a negative sloping scatter plot. And no reliable correlation is just, there's no relation at all. It's just scattered about evenly. It's not a negative slope, it's not a positive slope, it's just everywhere. There can be no relation with these. So basically, if we look at this, what can we tell about this slope? So as the x increases, so as we go from left to right, the points go from high to low, which means that it has a negative sloping, negative correlation. And basically, right now, we also learned about how if correlations are weak or strong, and what that means is a weak negative correlation would be maybe negative 0.0005x, for example. So this is still a negative slope, but it's like imperceptible, like it's very, very minor. That would be a weak correlation if if a scatter plot would present such a slope, like a sloping line like that. But on the other hand, so it doesn't have to be as imperceptible as the example I showed here with negative 0.0005, but something very minor, something that doesn't show such a negative correlation it's a little sloping downwards, but not really, kind of is a weak correlation. And then if it's sloping really drastically, however, like that, then it has a strong negative correlation. And as we can see with these points right here, this scatter plot right here, these set of points, it is a strong negative correlation because as we can see, it slopes down drastically. But then we also need to take into account of the x-axis. So even though we think that this might be a strong negative correlation, as I said, actually it's not that strong. That is because the y-axis is much higher. The things we're dealing with, the numbers, are much higher than the numbers right here. So in this case, yes, it's a very strong negative correlation that we can see with this scatter plot, but we still need to take into account the x-axis. So in this case, it doesn't really matter, but in other cases, it would matter. So in this case, yes, it is a very strong negative correlation. Next, we are going to look at least square lines. So a scatter plot can help you see patterns in data involving two variables. If you think there may be a linear correlation between the variables, you can use a calculator to find the linear regression line, also called the least squares line, that best fits the data. The graph at left shows the vertical distance from each point in a scatter plot to a fitted line. The fit of a least squares line is based on minimizing these vertical distances for a data set. A least squares line is one type of linear model for a data set. So basically, a least squares line is like the slope that you would give this right here, my scatter plot. So the linear line you would use to generalize this, basically. So let's maybe try this for a scatter plot. So I'm going to create a scatter plot right here. So yeah, that's a scatter plot. So see, if you go into settings, click on that, it has the options to make it a scatter plot or not. So done. Yeah, so if it's lines, it would be dotted dash, drag. But what we're doing right now is actually the scatter plot, so we can leave it at that. So why don't I put in 0, negative 3.2. Actually, this is the set of points given in the textbook, so that is what I'll be using for this example, 5.0. 6. Yeah, so those are our points right there. And if we zoom out a little bit, yeah, that is the scatter plot we're dealing with. So as we can see, this is a positive correlation sloping upwards. And what we're trying to find is the least squares line, which is basically like minimizing. So it's practically in the middle of all the points, like the median, you could say. So if we calculate that for this specific one in the textbook, if it gives us the line of y equals 2.05x minus 3.13. And if we zoom in, we can see that the distance between the point and the lines are pretty much the same. There's this much difference between this point, this much difference between this point. So it's very, very little, and it tries to be as in the middle as possible. So that is what the least squares line is, and what it does, how we can find it. So basically that is the lesson for today. Hopefully this video was informational, and see you in the next video, Algebra 2 section 1.6. Thank you.